Gas valves. This is possibly the hardest and the most difficult subject of fault finding and diagnosing whether these very complicated products actually work, and they're tested. But first of all, can I just remind breakdown engineers, gas safe engineers, please wear your gas safe card with you. Keep it in the pocket, so as the door opens, you can show to the customer, I am gas safe approved, and they can check it. If you are that customer and somebody is going to be working on your boiler, ask to see their gas safe card. If they can't produce it, close the door and find somebody else, because it is a requirement and it's a badge of honor and safety and competence. So if somebody turns up and hasn't got one of these and they say, it's in the office, I'm waiting for it, fine. Okay, come back when you've got it. And then find someone who has got one of these there. This is crucial, and especially for this subject, gas valves. So when we arrive into the house, the first thing we're going to do is have a look at the gas meter, because we have an awful lot of problems. So make sure that the isolating valve is in the vertical position. Check that the earth actually is connected correctly. And also a good idea is to spray leak detector fluid around the joints. And don't forget, your gas flue analyzer has an adapter for sniffing leaks. So use it there at the meter. Next, take a photograph. One landscape, one portrait, just so you can look back and say, yes, that's the proof, and everything at the meter is perfect. Before we can begin and take the casing off, we need to do our 4-part electrical test. And with our touch-free volt pen to make sure that the boiler is actually 0 volts. This is because electricity and water blow fuses, but electricity and gas make explosions. So we want to make sure that that boiler that we're going to work on is 101, 1001 dead from electricity. The first stage that we're going to do is to make sure that the spur is turned off, the fuse is removed, and we check it's 3 amps. At the boiler, as you can see, it's turned on. So I want to make sure that the spur in the off position is actually dead. We're going to need some tools. Firstly, our gas flue analyzer, because we will need to check that the emissions are correct. But with that gas flue analyzer, we also need some extra probes. One is going to be the gas sniffer, and 2, a manometer, because we have to check the pressure and digitally. So I don't like water gauges because they're not 100% perfect and they're awkward. So either the gas flue analyzer has a manometer built in, or as an accessory you need to buy, or you have one of these digital ones, but it has to have 2 terminals on the top, not this one. These have now been discontinued and banned. So make sure that you can measure the actual exact gas pressure. The first stage of this is make sure that the black lead common is secured to an earth terminal. Then we're going to move our multimeter to AC. So we've got the spur turned off, the fuse removed or unplugged. So what we want to see are zeros throughout the terminals. So let's start from the live terminal. How many volts have we got coming down onto the live terminal? None. Perfect. Neutral? None. Excellent. The common? None. And the return, switch live, none. So therefore this boiler is definitely volt free. One of the problems that we have with gas valves is the installer manual. Quite often there's information missing. For example, how many ohms on the gas valve between this terminal, that terminal, or the colour of the wire, or any sort of information on the wiring circuit or down in the fault finding flowcharts. So they're not all the same. I've looked at quite a few manuals for the production of this video, and I was, shocked, but I know the answer. Quite often they're just not there, and you have to phone technical. And that's why I made the app with fault codes. It has a phone number straight to technical, where you can get the answer while you're in front of the boiler. And the first thing that you need to do before you phone them up is to take a photograph of the identification plate, the serial number, the GC number, which model of that boiler is, because quite often gas valves will be replaced after 2, 3, 4, 5 years. So the manufacturer needs to know the serial number so they can say, right, you've got a Mark II gas valve and that has different values and different way of testing it. Another thing is practice. Well, a lot of training centres, including the factory ones, don't spend too much time on testing gas valves. But here on Wednesday, definitely, because I know this is an awkward, tricky job, and trying to find out exactly what goes on is difficult. So here we've got a dozen boilers plus some valves, and I show you exactly how to measure them so you can walk into this particular make and be better prepared. So the first thing that we need to do is just have a look at the serial number, because we may have to quote that, well, you will have to quote that to technical at the factory. So if we look at this, then we can see here which model and serial number it is. So I'm going to have a go and see if I can guess what it actually means. But if you can subscribe to our channel and leave us a like and answer me in the section below what the serial number means. So I'm going to have a go. So it's an Ecotech Pro 28 R2. So that means version 2. And then the serial number here starts with a 2. So that's UK version. The 1, I think, means that it's natural gas. But if it doesn't, can you leave me a comment, somebody who actually knows? The 09 means 2009, so we know that anyway. And then the last two numbers here, 29, is the week number of that year. So 29 weeks is going to be summertime, I would imagine. So we have to look in a book on 2009 to know exactly. But that information is crucial to technical to help you out, because as we can see, there's several versions which might have a different gas valve, a different pump, different sensors, different PCB. We need to make sure that they know what we're standing in front of. And that's why you need to use the fault finding codes app, because there you've got either a direct link into technical, which will be seconds away, or reception, who will pass you over to technical. I've seen many engineers leave a message on forum, said that I went there this morning and I got this and this and this, what should it be? And that's a complete waste of time, because they've just left the house cold, not working, and then sometime in the evening they're looking for help. Well, if you use the app as it should be used, you could just phone them up while you're there, and the technical department will say, right, change it or don't change it, whatever, and they'll give you help in seconds. And that's the way it's done. That's why breakdown engineers can do better jobs more intelligently. So first of all, let's move the multimeter into ohms. And we're going to check the multimeter is fine and the batteries. And we do that as we've shown before. Put an X, press it, 21, 22, the meter's refreshed, no battery symbols come up, so it's fine. I've looked in this particular manual, and there's the gas valve with a blue and a red, and they happen to come down here, the blue and the red. And the manual says it should be around 52 ohms. So if we remove the multi-plug, I can show you a close-up of this one, and you can see here that it's got 2 silver, a brassy, and 2 more silver. So there's 2 coils, and the brass one is normally earth. But we don't use earth here, we always use the earth where the yellow and greens meet. So here is another gas valve, and it's got 4 pins, you can see here. So as always, we measure from the first pin to the last pin. And that combined reading of the 1 or 2 coils is what the factory information needs to have. So that's just another way. So it's always first pin to last pin, and each pin to earth should be OL, open line. But that's the golden rule of measuring gas valves. Each pin that you do, so this one's got the 5 pins, ignore the earth in the middle. So if we go from the first pin to earth, it's always going to be OL, open line. Everything to earth is open line with electricity on boilers. It's dead easy to use. So to measure this coil, and it's showing 52 ohms, I go from the furthest one, so I'm going to put the black one here and the red one up this end, and just give the meter time to whiz round, put a few volts down, and here we are, exactly 51.6. That's near enough. This boiler's really old, and it's been in service until just a few years ago. So now, if we put the multi-plug back into its place, what I want to do is measure the leads, because that could be a fault, and that's the reason why it's not working. So as always, black goes first, the common, into the blue, and the red goes into the live terminal. And again, we wait and see, and there's our confirmation, 51.6 ohms. That means that the PCB, the leads, and the gas valve are all on the same wavelength. The next stage is going to be voltage. So we need to find out how many volts AC or DC is going into that gas valve. And that information you get from the installation manual or when you talk to technical. On top of most gas valves, you can see here where we've got our coil. And it's known as a modureg, modulating regulator. Basically, that's our dimmer switch to get the flames going up and down in the most economical way. And quite often, we don't know what they are. So why are they coloured? If somebody can leave a comment down below who actually knows, is it red ones are made in this country, green ones are made in another country, blue ones in another, or something completely different? I'd really like to know. So if somebody can help us out, that would be terrific. So the modureg, as I said, is a dimmer switch. Quite often, if you remove one wire from the terminal here, the gas flame burner will go down to low, and then we adjust it with the screw on the top. So we can only do that once we've read the installation manual and we've talked to technical, because you could do serious damage if you do this incorrectly. So this is crucial, crucial, crucial. We understand that when we turn the top or the nut underneath or the screw on the top, whatever, that we know what settings we are making. So therefore, when we put the 2 leads together in, it'll go into high flame, and there again, we can adjust it so it's not overgassed, and we need to check that with our app, which is gas rate. But that's on top of these things. So all we're really looking for here, the quickest way is to get a steady reading. That's almost certain to mean it's a good coil. The same as everything else. And here we've got a black one here, live, neutral and earth. And again, we don't need to worry about the earth so much, but the 2 pins, which is a plug, that will make the gas go to maximum. And then the dimmer switch on the top, the modureg, then makes it go higher and lower depending on the information it receives from the heating flow sensor or stat and the return heating sensor or stat. But that's where it gets this information to stop the boiler overheating. And obviously the other way around is to underheat. So this is an crucial test, and make sure that you understand a steady reading is almost certainly going to tell you that coil or this solenoid operator, which is basically maximum on-off, is actually working correctly. But as I say a million times, which is why people run away from gas valves, quite rightly, is phone the factory, get that information, and use that when you're going to a boiler to check whether the gas valve is actually working or it should be replaced by the latest version. You may come across a gas valve which has got two parts to it. So you've got a solenoid here and a solenoid there. This has got purple and blue, but sometimes both of these are the same color. It could be yellow, who knows what colors. And you need to make sure that the correct one is in the correct position. So what I always do is I get my felt tip and mark the top one here and then double check that it is the correct one by phoning technical, which is what I did here because they were the wrong way round. And this happens a lot, which is why we get error codes for gas valves. So any normal person would think, right, it's faulty. I'll buy a new gas valve, stick it in, plug it in the same way, and they get the same answer. It's faulty. What you should have done, of course, is phone technical and say, right, purple wires, is that on the top or on the bottom? And the blue wire, exactly the same again. Please do that. Don't just guess and think, right, I've got voltage in. Because when I looked in the manual for this Worcester Bosch SI25, in the flowchart, it said it should be one coil is 190 ohms and the other coil is 140. And when I spoke to the very clever person in technical, they said, no, your serial number says it should be 190 on one coil and around 390, 400 on the other coil. You see, this is the value of phoning technical to know exactly. Otherwise, I could be making a very expensive and time-wasting call to the spares department. The next stage is going to be, I need to find out where the purple and the blue plugs go onto the PCB and check the continuity and whether the coil is okay. So now we're going to move down to the PCB. Now we can see that we've got the blue on the top and then the purple underneath, completely the opposite way round. So you can make a very easy logical assumption that the purple on the top will be the first two colours. But there we are. This is the value of checking with technical and they tell you correctly. So now we need to measure it. Well, getting a multimeter into here is going to be a challenge. So what we're going to use is a special PCB available here, one per person on our fault finding course on a Wednesday. To begin testing the gas valve, we need to make sure that the meter is fine. We always do this, so we're going to make an X 2122. It's refreshed, therefore that's a good sign, nothing wrong with the battery. And we're going to test the blue wire to the gas valve, which is here. So we just put it in a hole, put in that hole, we just wait. So according to the manual, one coil should be 140 and the other's 190. Well, that's 175, so that's neither here nor there, so that's a bad sign. But let's just check the other gas valve here. So we'll just go into there, and we'll wait for the multimeter to zoom around, and we've got 400. Well, that contradicts the manual, but it confirms what the technical person said. One should be 190, and the other one should be 390, but 400. So this proves that this gas valve, not only were the leads plugged in upside down, but is actually faulty. So it needs to be replaced with the part number that technical gave us, so we can make sure that we order the correct one from the official spare stockist. Thanks for watching our video, and as always, take care.